This exercise was presented in the last video. It is asking which of the following numbers are rational numbers and which are irrational. And in the last video, I discussed rational numbers and what they were. Now you may wish to watch that video first. What I'm going to do in this video is talk about irrational numbers and then complete the solution to this exercise, which was only partly completed in the last video. An irrational number cannot be written as a fraction. Let's use this as an aid to understanding what we mean by this. You can see I'm saying an irrational number equals an integer divided by an integer. Well, this is not correct. This is a definition of a rational number. So if we were to think this, we would be wrong. So we cannot have an integer divided by an integer, giving us an irrational number. Let's move on and consider a fuller definition of an irrational number. An irrational number cannot be written as a fraction. We discovered that already. The decimal form of an irrational number does not terminate or recur. In other words, 0.75, which is an example we've looked at in this video, terminates. Now, an irrational number will not terminate like that. We've also got 2/3 being 0.666 recurring. We carry on writing the sixes. An irrational number does not recur in the way in which I've just described. Let's consider an example of the irrational number pi. And you can see it's 3.14159. And we have these three dots. Now, when we're dealing with pi, what these three dots represent is the fact that there are more digits. I can make pi more accurate. It doesn't mean that you're going to have a pile of nines just because this is a 9. It's not recurring. You will often hear pi described as being 22/7. Now, 22 is an integer and 7 is an integer. So you may think, oh, therefore it's a rational number. No, 22/7 is just an approximation to pi. It enables you to get a rough idea of the results of a calculation. Another example of an irrational number is the square root of 2. Now, the square root of 2 is 1.414213, and these three dots are telling us there are more figures. It is not recurring, there's just more figures, and as you add more figures, you get a more accurate value for the square root of 2. If you had to use the square root of 2 in a calculation, you may just want to use this bit of the number. But in fact, you could choose to go for the following value that's coming into view now, where the square root of 2 is 1.414. Now, this is not equals, but it is an approximation to the square root of 2, and it might give you sufficient accuracy in the calculations you're carrying out, so long as you realize that the result you get is not accurate, it is just close to the value. So what we can say is this is more approximate than the one above. At the beginning of this video, we were presented with this exercise, which asks, which of the following numbers are rational numbers and which are irrational? You should now be able to look at the numbers and make a decision as to which are the rational numbers and which are the irrational numbers. So let's have a look at the answer. We can see that the majority of the numbers were rational, and we have, in this case, just one irrational number, the square root of 2. The understanding of rational and irrational numbers is essential for the work on surds. We will now take this understanding of rational and irrational numbers forward to the next video, which is an introduction to surds.